Assalamu alaikum. Today we are going to discuss the pH and we will calculate the pH of a strong acid and a weak acid. Here are the learning objectives. Understand what is the pH scale, compare the strong and weak acid, and then calculate the pH for a strong acid and a weak acid. Here are some real-life applications of the pH. The pH of a soil should maintain at a specific level for the good yield of the crops. The maintaining of the pH of the swimming pool, otherwise it will irritate the eyes. In cross-curriculum link, it is related to medicine and the biology, in which the pH of the blood must be at a specific level, which is important for survival. First, we will discuss what make a solution acidic or basic. Acid is something which will give you H plus or hydronium ion in the aqueous solution. Its pH on the pH scale should be less than 7 and it should give H plus ion and it turns the blue litmus into red, whereas the base is one which accepts the H plus ion and its pH is greater than 7. Let's talk about what is the pH scale. pH scale is basically a logarithmic scale which will give you the numbers which will tell you that something is acidic or basic. If the number of a substance is 7, it means it is neither acidic nor basic, it is neutral. If this number is less than 7, then the substance would be acidic, and if this number is greater than 7, then it would be a base. Just like lemon juice, its pH is less than 7. For the water, its pH is 7, which is neutral. And the pH of the baking soda, it is above 7, so it is basic in nature. The logarithmic scale is used because it is basically the negative log of H plus ion or the concentration of the hydronium ion. Because it is a big number, so to convert into a smaller number, we will use a logarithmic scale. Now, let's see what is the difference between a weak acid and a strong acid. A strong acid is one which will undergo complete dissociation. For example, when we talk about HCl, it has one hydrogen ion, it will give you one hydronium ion, and it means it is undergoing complete dissociation. On the other hand, if we talk about the acetic acid or ethanoic acid, it has 4 hydrogen, but it will give you only one hydronium ion. It means it is partially undergoing dissociation, so it is a weak acid. Here are the few examples of strong acid and weak acid. Now let us see how we can calculate the pH of a strong acid. For example, if you know that there is a solution of a acid which is 0.01 molar HCl, so we will use the logarithm formula pH, which is equal to negative log of concentration of the hydronium ion. We're going to use this formula to calculate the pH of this. Find the pH of HCl of 0.01 molar. Now, you can see that it is about HCl, which is a strong acid. It will undergo complete dissociation. For example, initially it was 0.01 and the initial concentration of hydronium ion and chloride ion was 0, but when it undergoes dissociation, it will become 0 and the concentration of hydronium ion will become 0.01, which can be written as 10 raised to power minus 2. Now, the formula is pH is equal to negative log of concentration of hydronium ion. We know that in the logarithm that log of m raised to power n is equal to n log of m. It means the pH of minus log of 10 raised to power minus 2 can be written as minus 2 log of 10. Now this negative sign gonna cancel out. So it will become 2 log of 10 and log of 10 is 1. So its pH would be 2. We can use the same concept for the calculation of the pH of the weak acid, but for the weak acid, we have to create an ICE table. I is the initial concentration, C is the change in concentration, and E is the concentration at the equilibrium. Let's see an example. Calculate the pH of a weak acid. It is about the ethanoic acid, acetic acid. You can see that it is 0.5 molar per decimeter cube solution of acetic acid, which has dissociation constant of 1.8 times per minus 5, and we have to calculate the pH of this solution. This is the chemical equation, which is showing that it is partially undergoing the dissociation, and this is the acetate ion, and this is the hydronium ion, and this is the acetic acid. The formula for the dissociation is written as this. First, we're going to put the values into the ICE table. Initially, it was the concentration of acetic acid was 0.5 mole per decimeter cube. The initial concentration of hydronium ion was 0, and for the acetate ion it was 0. After some time, it changed to minus X. X was the concentration of hydronium ion and X was the concentration of the acetate ion. It means that at equilibrium, the concentration of acetic acid would be 0.5 minus X. X is the concentration of the hydronium ion and X is the concentration of the acetate ion. Because it is a weak acid, it means that we can say the initial concentration and the final concentration are almost same. It means 0.5 minus X is almost same as 0.5, which is the initial concentration of the acetic acid. Now, we're going to put these values into the formula. The value of dissociation constant Ka is 1.8 times 10 raised to power minus 5. For hydronium ion, it is X. For the acetate ion, it is also X divided by the concentration at equilibrium, which is 0.5 minus X. As I told you that it is almost equal to the initial concentration. Therefore, we can write it as 1.8 times 10 raised to power minus 5 is equal to X square over 0.5. Now it's going to multiply on this side. So X square is equal to 9 into 10 raised to power minus 6. Now to get the value of X, we have to take the square root on both of the sides. So X is equal to 3 into 10 raised to power minus 3. Now we got the concentration of X, which is the concentration of hydronium ion, and that is equal to 3 into 10 raised to power minus 3. To calculate the pH, we will again use the formula of pH, that is equal to negative log of hydronium ion. It means it is equal to negative log of 3 into 10 raised to power minus 3, which can be written as 0.003. And if we solve it by using the calculator, we will get the value of pH, that is equal to 2.5. This is the concentration pH value of the weak acid, acetic acid, that we have used in this equation. And here are the questions related to the topic, like what is the strength of the acid? If it is strong, what is the strength of the acid? Is weak? What is the method of calculation? And what are the real world applications? Thank you.